Okay. Eight and nine, we are just going to go ahead and find the difference quotient. Oops. So f of x plus h first. We want x plus h cubed. Now there's a real simple way for expanding out x plus h raised to any positive integer. Right, makes use of a very important result out of algebra known as the binomial theorem. Right, what it says is for any real numbers, x and y, and any positive integer, n, x plus y to the nth power equals summation from I equals 0 to n choose I, x to the n minus I, y to the I. Right, where n choose r is defined as this formula, n factorial over r factorial times the quantity of n minus r factorial. Is the nr binomial number, right? Now this is rough. Especially if you're trying to do this by hand. However, there is a really nice way of finding binomial numbers aside from that formula. An object called Pascal's triangle. Here's how we form it. It's ones down the sides, and then each middle term is the sum of the two terms that are diagonally above it, right? So it's 1 plus 1 is 2. So the next row would be 1. 1 plus 2 is 3. 2 plus 1 is 3. And then 1. The next row would be 1. 1 plus 3 is 4. 3 plus 3 is 6. 3 plus 1 is 4. And then 1. There would be the fifth row, so on and so forth. And this goes on forever. As it turns out, every single entry in Pascal's triangle is a binomial number. As an example, let's do 5 choose 3. The 5-3 binomial number. Here's how you find it. Go to Pascal's triangle. Look for the fifth row, right? This is the 0 row. So it'll go 0, 1, 2, 3, 4, 5. This is the fifth row. Now look for the third entry. And again, it starts at 0. 0, 1, 2, 3. Five choose 3 is 10. The 5-3 binomial number is 10. Now to go to expanding. All right, so how can we use this to expand? I'm going to use the fifth row again. So I'm going to say x plus y to the fifth power. Here's how you do it. Exponent's going to tell you what row you want to be in. Right, so row 5, I already have the arrows for it. You're going to start x to the fifth, y to the 0. Y to the 0 is, of course, just 1, right? Plus. Write out the terms where the x power is decreasing by 1 each time, right? So 5, then 4, 3, 2, 1, 0. And your y exponent's increasing by 1 each time, right? So y to the first, second, third, fourth, fifth. The coefficients of each term are exactly the entries in Pascal's triangle. So it'd be 1, 5, 10, 10, 5, 1. And there's x plus y to the fifth power. This is a very quick method of expanding x plus y to any positive integer power, right? Instead of writing it out as you would in algebra, right? X plus y times x plus y times x plus y times x plus y times x plus y, and then foiling all the way through. You don't really need them. Right. All I did was I introduced this as the theorem, right? But we're never really going to be using it per se. This is the shortcut that I'm going to be using. Right. So summation, you'll cover in both discrete math and calc 2. You look at that, you look at summations more in depth there. And factorial, same thing. You'll study factorials a little bit more in discrete math and calc 2. Right. I'm going to use this now to expand out the x plus h cubed. Ready? Highest power is 3. So it'll be x cubed plus. If we come over to Pascal's triangle, we want the third row. 1, 3, 3, 1. 3x squared h plus 3xh squared plus 1h cubed. There's x plus h cubed expanded out. Excuse me. Right now, take what we just calculated. Thank you. I want, that's copyright, yes. Like we just calculated and subtract out f of x, which is x cubed. X cubed minus x cubed is 0. So what are we left with? 3x squared h plus 3xh squared plus h cubed. right? Finally, take what we just calculated and divide it by h. And you can factor out an h from the numerator, and we're going to be left with 3x squared plus 3xh plus h squared. You have h over h, that's just 1. And so we're left with 3x squared plus 3xh plus h squared. That is our difference quotient for this function. Right? Difference quotient for g of x equals 1 over x squared. They are. First, we want g of x plus h. Right? 1 over the quantity of x plus h squared. We can expand that out. However, I think I'm going to leave it. Now, take what we just calculated. Subtract out a g of x, or 1 over x squared. Now simplify that. When adding or subtracting two fractions, what's the rule? Right? You need a common denominator. More specifically, you need the least common denominator, right? The LCD. In this case, the LCD is the product of the denominators, x squared times x plus h quantity squared. What we're doing, right, is we multiply each term by the common denominator over the common denominator. All right, remember that? What's really going on is we just take a look here at this first term and we go, okay, what term is missing from the common denominator? It's the x squared, right? So we're multiplying the numerator by x squared. And you play the same game with the second fraction. We are missing an x plus h squared from that denominator, right? So we're going to multiply the numerator, the -1, by an x plus h squared. What we're going to do is go ahead and expand the x plus h squared in the numerator. Again, that is a common expansion, x squared plus 2xh plus h squared. Notice we have an x squared minus x squared, that's 0. We are left with negative 2xh minus h squared over x squared times the quantity of x plus h squared. While it's not necessary, I'm going to rewrite this by factoring out the negative from the numerator. Right? And the reason for that, for me, is because I don't like negatives. And so to me, it's more aesthetically pleasing to have a single negative out in front than having the two negatives in the numerator. Right, now what we do is take what we just calculated and divide it by h. When you have a complex fraction like this, what's the rule? So what's the rule for simplifying a complex fraction? What do you mean solve? Hmm? You're probably going to face palm. So I promise you do know it. You just don't know that you know it. Take the numerator. And multiply by the reciprocal of the denominator. Remember that? And then when you multiply fractions, you of course just multiply straight across. I'm also going to go ahead and factor out that h that you suggested in the numerator. Then you have h over h, which is 1. And we are left with negative 2x plus h over x squared times x plus h quantity squared. And so it is custom, it's tradition to leave the denominator factored like that, not to expand out and distribute the x squared through. Are you incorrect if you do it? No, right? So you could also write it this way. Or this way. Right? They would all be equivalent. Okay. Okay. Starting with what a function is. Uh-oh, what's going on? Ah, I know what. 2. Says it's paired. Move. And let's just add another one. There it is. Connect. There was my mouse. Okay, now it's working. Excellent. All right. I mean, you can if you want to. I'm going to tell you what a function is. So what I'm going to do is I'm actually going to go ahead and move this for right now. So a relation. You should all be familiar with this, right? Equation of a circle of radius r centered at the origin. This is what's known as a relation. So a relation just simply relates an x value to a y value. It's typically written as a set of ordered pairs, so I could do this. This would be a relation. A function is a special type of relation. It is a relation in which each x value goes to only one y value. This happens to be a function as well. We also have what's known as the vertical line test for functions. So if you're given the graph of a function, or I'm sorry, not function, if you're given the graph of a relation, I'm going to start with a simple one. Vertical line test says you draw an imaginary vertical line. As you slide that line right along the graph. If it intersects the curve more than once at any point, it is not a function. Did not want to turn you to a different color. So if we look at is a terrible looking circle. That is a better looking circle. When we look at a circle, this is clearly not a function. Right? Intersects the curve in two locations. Now, this, of course, means that this x value, whatever this x value happens to be, corresponds to two different y values. Now, there's one input corresponds to two outputs. When writing out a function, right, we'll typically represent it as f of x, g of x, h of x, you know, some lowercase letter or some letter, some symbol of x, right? So this is the function, right? So f is our function. Of x. That x is the independent variable. Uh-oh. Problems 1 through 5, we're going to be given a relation, an equation. And we're going to be asked to determine whether it defines y as a function of x. So remember what you have to ask yourself. For y equals x squared plus 4. For each x that you put into the equation, do you get one y value only? Right? In this case, we do, right? Each x corresponds to one y value. Yes, right? So if we do 1, it's going to be 1 squared plus 4, right? That's always 5. It's one value. It doesn't matter that -1 is also 5. That's fine. Right? We just can't have 1 being two possibilities, right? So we can't say, so if we put in 1 and we got it could be either like 3 or 8, then that wouldn't be a function. So there's no work to be done here. This is clearly a function. But now, let's look here. X equals y squared plus 5. Right? Well, let's try and solve this for y. Well, the first thing you're going to do, right, is subtract both sides by 5, right? We get y squared is x minus 5. Take the square root of both sides. Square root of y squared is equal to the square root of x minus 5. But what is the square root of y squared? Is it y? What is the square root of -2 squared? It's 2, isn't it? That's not -2. It'd be the absolute value of y. So the absolute value of y has to be square root of x minus 5. All right. The interpretation of that is y equals negative square root of x minus 5. Or y equals the positive square root of x minus 5. Right, so that symbol is the symbol for or. Right, what this means is it's not a function, right? Each value of x has 2 corresponding y values. So if we put in 8, we'd get negative root 3 or positive root 3. So this is not a function. Well, let's look, because this one is a square root, right? Y equals the square root of x minus 5. If you plug in an x value, let's say, again, let's go with 8, do you get one y value, only one y value? If x was 8, you get what? Square root of 3, right? This one is a function. So square root of -3 is a complex value, which we're not considering just yet. Right? This one is a function. In fact, for here, you wouldn't be able to have x being less than 5, right? To give you square root of a negative number, which is complex. For now, we're only considering real values. What about y equals 5? What do we think? Would that be a function? Why do you say not a function? True, x can be anything. So pick a value for x. Do you get only one y value? And so if x is 6, what's y? Right? So yes, this is a function. Again, because it's y is a function of x. Doesn't matter that every x value gives you the same y value. That's fine. What's important is that each x value has only one corresponding y value. X squared minus y squared equals 36. Right? This would not be a function. Let's see why. And so first we'd add y squared to both sides. Subtract 36 from both sides. Take the square root of both sides. Gives us that the absolute value of y is the square root of x squared minus 36. And again, that leaves us with two options. Y is negative root x squared minus 36, or y is the positive square root of x squared minus 36. So we get two possible y values. Hence, it's not a function. There we go. Looking at function notation. So we're told that f of x is x squared minus 4x plus 2. I want to find the following. Okay. So this is the definition of f. X squared minus 4x plus 2. F of 5. Five is our input. What we do is in the definition for f, everywhere there's an x, replace it with 5. All right, 5 squared is 25. 4 times 5 is 20. So we get 7. This 7 is called the output. F of 5 is equal to 7. All right, so that would be represented, if you wanted to represent as an ordered pair, 5, 7. Right? You might also see 5 maps to 7 through F. Right. This bit here is really for more more advanced study of functional analysis, so it's really not going to be used too often. It's really these two right here that are going to be used the most. F of 5 equals 7, or it's the ordered pair 5, 7. F of -3. So now we're inputting -3 into F. Well, -3 squared is 9, right? -4 times -3 is positive 12. You get 23, right? So F of -3 is equal to 23. F of A. Now our input is some value A, some arbitrary value A. Just like with numbers, all we do is replace X in the definition of F with A. A squared minus 4A plus 2. Now I want A plus B, F of A plus B. Again, everywhere we see an X, replace it with an A plus B. As a general thumb, we want to simplify our answer. So we have to expand out A plus B squared. So that is a special algebra formula. Remember that? A squared plus 2AB plus B squared. Distribute the -4 through. This is -4A minus 4B, and then just that plus 2. There's sadly no common terms here, right? There's nothing we can simplify further. That is how we would leave our output. And then finally, we have f of a plus f of b. And we already know what f of a is. Yeah, it's part of the a plus b quantity squared expansion from algebra. So there's f of a. F of b would just be b squared minus 4b plus 2, wouldn't it? And now we simplify. The only common terms are the constants. 2 plus 2 is 4. This would be then our output, our formula for f of a plus f of b. A squared plus b squared minus 4a minus 4b plus 4. Okay. It's better. Right? G of h. Well, remember what we're going to do. G is a function in this case, right? So we look at the definition of G. Everywhere there's an X, we're going to put an H. Be negative 2h squared plus 3h. Right? What about g of x plus h? Everywhere there is an x, replace it with x plus h. Expand out x plus h squared. I'll go ahead and distribute the 3 through, right? So that becomes 3x plus 3h. Now distribute through that negative 2. And if there are no common terms, that is what we would leave for g of x plus h. G of x plus h minus g of x all over h. This is called the difference quotient of g. So this value is very, very important in the study of calculus. So typically how I tackle difference quotient problems is step by step, just so the algebra doesn't seem daunting. All right, first step that I do is I calculate g of x plus h. Well, we just did that. No need to do it again. Next, I take what I just calculated, right? That g of x plus h. What am I doing? I don't need to do all that. I can just paste again. No. Subtract from it g of x, which was negative 2x squared plus 3x. Negative 2x squared minus negative 2x squared is 0, right? So they drop out. We have plus 3x minus plus 3x. That's also 0. This is what we're left with. Negative 4xh minus 2h squared plus 3h. Finally, what I do is take that we just calculated and divide it by h. Now look what we have in the numerator. Every term has h common to it, right? Factor it out. H divided by h is 1. But we're left with negative 4x minus 2h plus 3. That is our difference quotient. Are there any questions so far? You mean the g of x plus h minus g of x over h? This bit here? Yeah, so that is the difference quotient, right? So if it's a different function, right? So if it's f instead of g, then it would just be f of x plus h minus f of x over h. But yes, whenever we refer to difference quotient, this is what we're referring to right here. The h may sometimes be a delta x. Right, so you may see it written this way. And again, it doesn't have to necessarily be x. It's whatever the independent variable is. Right, so again, if I said up here, instead of g of x, let's say it's g of t, then you just replace x with t. Right. In terms of the h, it is customary to use h. But some texts will use delta x or delta, whatever the independent variable is, right? Delta t. For tests and quizzes, I will always use h in this course. Crap, I went over. I was thinking 745 instead of 740. Oops. Okay. Now moving on to domain and range. Okay. So when we write out a function, right, you typically write it this way: f from A to B. The set A is called the domain of our function, right? So it's the domain of f. The set B is called the codomain of f. Right. So for example, we can say f is a function from the real numbers into the real numbers defined by f of x equals x squared. Okay. So what this is saying is that our domain of f is x squared. I'm sorry, the domain of x squared is all real numbers. So the domain of a function is the set of all values that, how do I want to word this? That can be, let's do that, input into the function. Right. So for example, the domain of 1 over x is all real numbers except for 0. Right, so it's negative infinity to 0 unioned with 0 to infinity. Another example. The domain of the square root of x is all real numbers, 0 and larger. Right? right? So the half closed interval 0 to infinity. Right? The range of a function is the set of all values that the function can evaluate out to. The syllabus is located on Teams. Click the Files tab in the Class Materials folder. So for example, the range of x squared is all non-negative real numbers. Right? So it'd be 0 to infinity. Notice that the range and the codomain do not have to be the same. So the range needs to be a subset of your codomain, right? All the numbers from 0 and up, they're real numbers. Right? So that would be a subset of all real numbers. That is a very important distinction. However, we will not be working with codomain in this course. We will strictly be working with range only. As another example, if we look at the range of 1 over x, right, that'd be all real numbers except for 0. Right? 1 over x, you can never get 0 out of it, but you can get every other real number. Right, so for problems 1 through 6, we're going to determine the domain of the function. Well, again, remember, the domain is the set of values that you can input to the function. There are 2 rules to keep in mind. You can't divide by 0, and you can't take an even root of a negative number. There's no denominator. And there are no radicals. So the domain is a set of all real numbers. Now, keep in mind that domain is a set. Right? Can be represented in two ways: set notation and interval notation. For real numbers, this is set notation. Right? It's a blackboard bold R. This is known as interval notation. You just write it as an interval. Right? Square roots. You can't take the square root of a negative number. Right? Specifically, any even root, right? So you can't take the fourth root of an even number. Right? Or the sixth root. Right? Because what happens when you raise a negative number to an even power? It goes positive, right? That is correct. Monday, Wednesday, Thursday, 6 p.m. to 9:30 p.m. Domain of 5 over x squared minus 9. So we have a denominator. That denominator cannot be 0. So x squared minus 9 cannot equal 0. That means x squared cannot be 9. That means the absolute value of x cannot be 3. X can't equal negative 3, and x can't equal positive 3. All right, so that's the symbol for and. There are no radicals here, right? So our domain, right? There is interval notation. Negative infinity up to negative 3. Unioned with negative 3 to positive 3. Unioned with positive 3 to infinity. This is the interval notation for that set. Or for that domain, rather. Set notation. Set of all x. If you want to get technical, set of all real numbers x, such that, and I'm going to write it this way, the absolute value of x does not equal 3. Unless the problem specifies, it does not matter if you represent domain in interval form or set form, right? Interval notation or set notation, it doesn't matter. All right, so again, this is read the set of real numbers x on that. Oops, that bloody arrow's in the way. All right, so that is read the set of real numbers x such that the absolute value of x is 3. Right? In other words, it's the set of all real numbers except for positive and negative 3. Okay. This function, again, we have a denominator, right? So what's in the denominator cannot equal 0. You can factor out an x. Remember, when solving a quadratic, you want to try and factor it first. If it can't be factored, then we'll have to use quadratic equation. Can this be factored? It can. Right, that factors to x minus 4 times x plus 6. The zero property of real numbers states that if the product of two or more real numbers is zero, then at least one of the numbers is zero. As a corollary to that, if the product of two or more real numbers is not zero, then none of the numbers can be zero. What that means here, right, is x cannot equal zero, and x minus 4 cannot equal zero, and x plus 6 cannot equal zero. Right? Because we're saying that the product of these three numbers is not zero. That means none of them can be zero. So x is not zero, and x is not 4, and x is not negative 6. There's no radicals anywhere, right? We don't have a square root, a cube root, fourth root, whatever. Therefore, our domain is the set of all real numbers except for negative 6, 4, and 0. Yes. Right? The only way you can get a product of zero is if at least one of the numbers is zero, right? 0 will give you a 0 in here. 4 gives you a 0. That's from here, right? 4 minus 4 is 0. Same with negative 6. There's no other way that one of these is 0, is there? So those are the only three possibilities. right? I mean, ultimately, what this is working out to be is if instead of not equal to 0 here, I said equals 0, right? And then it's like an algebra problem, right? You should have done that in elementary and intermediate algebra, algebra 1 and algebra 2. Well, I just wrote that down as 6. It's not. It's number 4. Square root of x minus 5. We don't have a denominator, so we don't have to worry about that. But we do have a square root. That means that what we're taking the square root of, in this case, x minus 5, has to be greater than or equal to 0. Which means x is greater than or equal to 5. So the domain is the half closed interval 5 to infinity. Or in set notation, that's correct. The bracket means that that endpoint is included. Unless the problem specifies otherwise, it does not matter which notation you use. So there's our domain for this function. Again, no denominator, so we don't have to worry about the denominator being 0. We do have a square root. That means that x squared minus 8x plus 12 has to be greater than or equal to 0. Solving inequalities, what you want to do is first find what's called breakpoints. Breakpoints are where the function is 0 or undefined. Since we're not dealing with a fraction here, we don't have to worry about the undefined part. what we first want to do is find where is it equal to 0. Right? Well, this can be factored. It's x minus 2 times x minus 6. So breakpoints would be 2 and 6. Right? Now, the idea behind this is simple. The only way to go from positive to negative or vice versa is if you actually cross through 0, right? There's no other way to go positive to negative or negative to positive except to go through 0. That's why we're finding breakpoints. What we do now is set up intervals. All right, so we take the set of real numbers and we break it at the breakpoints. So the first breakpoint was 2. The second breakpoint was 6. Right? Now go back and look at the expression again. X squared minus 8x plus 12. It'd be easier to actually look at its factored form over here. Look at each interval. I'm going to move that over. There we go. Pick any value within the first interval. Because we weren't doing an inequality. Right, that was just straight up does not equal 0. Here we're solving an inequality, so we need breakpoints. Right? So first interval, pick any value within it. Easiest value is 0, right? Plug it back in. 0 minus 2 times 0 minus 6. Negative times negative is positive. It gives us a positive value. Pick any value between 2 and 6. 3. 3 minus 2 is positive. 3 minus 6 is negative. Right? Positive times negative is negative. And then pick any value 6 to infinity. 10. 10 minus 2 is positive. 10 minus 6 is positive. Positive times positive is positive. Now we go back and we look at the inequality. Was the inequality greater than or less than? Greater. The greater tells us we want the intervals that are positive. Now you look back and you go, is it greater or greater than or equal to? Right? It's greater than or equal to, right? That or equal to tells us that the breakpoints are included. And if I just write it in inequality notation, that is x is less than or equal to 2 or greater than or equal to 6. Right, the domain would then be negative infinity to closed 2 union with closed 6 to infinity. Right, so final domain question. Cube root of x plus 1 over x cubed minus 8. The denominator cannot be 0, right? We have a denominator. The denominator is the cube root of x cubed minus 8. That is not allowed to be 0. That, of course, means that x cubed minus 8 cannot be 0, which means x cubed is not allowed to be 8. Cube root of 8. Is 2. That means x can't be 2. Now, we have a radical. Right? It's a cube root. But it's odd. You are allowed to have negatives under an odd radical. So the only restriction is x can't be 2. And so there is our domain. Any questions on domain before we move on to range? Perfect. So for 7 through 11, we are going to determine the range of the function. Now remember, range is the set of all values that the function gives us. Well, f of x equals 4. There's only one value it gives us. The range is the set 4. Remember, range is a set. That makes no sense. Right? So you can't write that. In this case, because it's only one value that the range can be, you can't use interval notation, right? You have to use set notation. It's just a set of 4. Right, let's look at 4x plus 3 over 5. You want to determine the range. Here's how we do it. Let f of x be some arbitrary value. Call it k. That'll mean that 4x plus 3 over 5 is equal to k. Solve for x. That means x is 5k minus 3 divided by 4. Look at 5k minus 3 divided by 4, and you go, okay, are there any values here that k cannot be? Right? The answer is no, right? It can be anything. So your range is all real numbers. or an interval notation, negative infinity to positive infinity. All right. So what about 4x minus x squared? All right. Again, we're going to let f of x be some arbitrary value k. That would mean that 4x minus x squared is equal to k. Solve for x. Right, we get x squared minus 4x plus k is equal to 0. That means x. Right? We have to use the quadratic formula here. Remember the quadratic formula. Negative b plus or minus the square root of b squared minus 4ac all over 2a. For here, we get 4 plus or minus the square root of 4 squared minus 4k all divided by 2. This implies that 16 minus 4k has to be greater than or equal to 0. Right, that'll give you k is less than or equal to 4. And so that is our range. Range is negative infinity to 4, closed at 4. Another fairly simple one here, once it decides to sync and show up. All right, so this is a piecewise function. So called because the function is broken up into pieces. Right? We mathematicians are a lot of things, but creative is not one of them. We just look at this and go, oh, look, this function's in pieces. Ah, piecewise function, perfect. Meeting adjourned, right? So we want the range of a piecewise function. Well, there's only two outputs that we get out of this, right? 4 or -4. So there's our range, the set of -4 or 4. Right, and last one. Take this piece by piece. So let's start with the first piece. For x greater than or equal to 2, k is equal to 4, right? Because again, what we're doing is we're saying let f of x be some value k. So the range of values for that first piece, just 4. Now let's look at the second piece. Right? For those values, -1 less than x less than 2, we get k is equal to -x. Which of course means that x is equal to -k. Now what we do is we take this and plug it back into the inequality. Right? So this implies that -1 is less than -k is less than 2. Means 1 is greater than k, which is greater than -2. Which looks weird, right? So rewrite it as -2 less than k less than 1. So the range of values for that second piece is -2 to 1 exclusive, right? Open interval, -2 to 1. For the final piece, yeah, okay, that's right. For x less than or equal to -1, k is equal to x plus 2, which means x is k minus 2, right? Now we do the same thing. That means that k minus 2 is less than or equal to -1. And so k is less than or equal to 1. The range is the union of these three sets. So before unioned with the interval, open interval, -2 to 1, unioned, not -1, sorry, 1 to infinity. I'm sorry, negative infinity to 1. Closed at 1. If you look at -2 to 1, isn't that contained? Negative infinity to 1, right? Aren't all those values in this interval, this last interval? So we can simplify this to this. So the range is negative infinity to 1 inclusive, unioned with the set 4. Are there any questions on domain and range?